Takže dneska lehčí téma. English? Okay, in English. So today a little bit lightweight topic. ClojureScript and Figwheel. Why it should be the next generation of the front-end and UI development again. So a little bit from the history and about the infrastructure and the platform itself. The basics of the platform are the Clojure language, which is a Lisp dialect, not compatible with the original Lisp, and also not compatible with some classical Lisp dialects. The original author is Rich Hickey, and this guy is mostly working on huge systems which are heavily using parallel computation. And thanks to the fact that the processor producers are now producing not higher frequencies, but they are giving us more cores, and the traditional languages have issues with multi-core systems. So from this frustration, Rich Hickey has started to develop a new language. The first publicly available release was by the end of 2007, but he has been working on that for more than 2.5 years by his own, with no funds, anything. There's a rumor that the current implementation is the 7th. So first 6 were not good. And yeah, after some community development, the first stable release has been released at, I think it was May 2009. Yeah, as I said, Lisp dialect, so I think most of you have heard something about the bracket hell. But when you get used to it and to the prefix notation, you find these type of languages quite powerful. So as the language has gained some attraction from the community and from developers, in 2010, David Nolan, together with Rich Hickey, has started to develop a ClojureScript, which is a Clojure version, let's say, for the browser. So on the language level, it is fully compatible. And on the language library level, it's something like 98.5. There are some parts of the Clojure library you cannot port to the browser. So for example, using the I/O is really impossible at the moment. But for example, the reactive extensions which are in the the reactive extensions which are in the language has been ported to the browser, even if the browser is allowing only one thread. Even if we say that it's a Clojure script and you think that the Clojure is getting compiled into the JavaScript itself, it's not directly JavaScript. It's a special version of JavaScript which is, let's say, friendly to the Google library called Clojure. There is really no connection between these two libraries, and it's one of the most bad syntax pronunciation in the world, because you never know if they are speaking about the Google Clojure library or if they are speaking about the Clojure language. So there is a special version of the JavaScript which is then given to this Google Clojure library, and this library can optimize the JavaScript. It can cut off unused code. There are some tree shaking methods there. Well, the JavaScript which is produced for the Google Clojure library is nothing you want to do manually. It's really brutal. But at the end, we have a code which is running in the browser. There are also generated these map files, so you can debug it. So it's as usual as you are used to in the front-end development. Another part of the platform is Leiningen, called Lane. That's something the Java guys know as Maven and or Gradle. .NET guys, I don't know, MS Build maybe, something like that. It's a project management tool, scaffolding tool. You can handle the dependencies there. You can build the project, test the project. You use it for the continuous integration. So everything which needs to be handled around the project and the content itself, not the code, is done via this tool. Nice thing is it's compatible with the Maven infrastructure. So if you are using the Java libraries you are used to, you can use them directly via the Leiningen, and also the libraries which are produced by Clojure can be uploaded into these repositories. As we have, how it is called, mvnrepository.org or JFrog or Bintray, or these popular Maven portals with libraries, there is a Clojure portal called Clojures, I believe, which is used for the Clojure libraries. Maybe just one step back, just to show you how the project file for Lane looks like. Those people who are used to Maven or Gradle will maybe those who are using Gradle. It's just a function with parameters, or how to call it, attributes. The double dot word, that's a symbol, so that's something close to a hash map in other languages. And you just put information there. So the dependencies, that's exactly libraries you want to use. Java options, plugins, these are Leiningen plugins. So if you want to extend the system itself by some additional features, you put plugins there. There is also an interop with the npm flow from the JavaScript world, and then there is something specific for the ClojureScript build itself, for the Figwheel, which we are going to speak about, etc. It's pretty straightforward. Nothing new. Just the syntax is slightly different. Yeah, Reagent. If you are developing single-page application or any front-end application in ClojureScript, you have three options what to use as a, say, component or the UI library. Directly from David Noland, which is the inventor of ClojureScript, there is a library called OM, which is very powerful, very complicated, and you need to be a genius to use it correctly. So there is already an ongoing project called OmNext, which is trying to simplify the library and make it a little bit more usable, because when you read the Hello World example, you already are out of your mind. Second option is some library which has nearly no community, nearly no development there, so that's already a no-go possibility. And one of the most favorite library is the Reagent, which is a library built in ClojureScript, but it's fully built on top of the Facebook React library. There is a nice thing about the Reagent library. You don't need to use JSX. It is using a library called Hiccup, which can be used also for the backend development. And the idea behind this library is that you are not writing HTML directly. You are creating functions which are producing data structures which are describing how the HTML document object model looks like. I will show you. The Reagent library also contains its own version of Atom. Few words to Atom. Atom is a data structure in Clojure which allows you immutability, because Clojure is a functional language and there is no immutability allowed, really. There is still a way how to do it in a safe way. So Clojure itself has a data structure called Atom, which can be used as a mutable object, but it's always recommended to use it just locally. So if you have immutability in Clojure or ClojureScript, you have it only local, for example, only in one function call. And Reagent has an improved version of the Atom, improved because we have this very nice feature of the single way data flow binding. So the React library needs to know what data structures has been changed to identify which components need to be re-rendered. And that's exactly the feature which is inside this special version of Atom. Anytime you change the state inside the Atom, the library knows which component has been bound to this Atom and will force the regeneration. At the end, it's quicker than the React itself, somehow. Also, to this project belongs additional libraries which we are used to use at the front-end development, like the routing, much more improved application handling, event signaling, etc. Figwheel. So now we finally go to that magic word, which is the tool which is helping us to develop the front-end application and the UI faster. In the definition is hot code loading during coding. Generally, it's nothing new to have a tool where at the moment when you save your source files, it gets compiled and it gets pushed to the browser, so you have a fresh version of that source file in your browser. It's really nothing new. But in this case, because we are in the functional programming and the state of our application is totally separated from the UIs, the Figwheel library can handle these two parts of the application separately. So we have an application state and we have an application code. So at the moment, when you change the application code, it compiles the new version, pushes it into the browser, changes it, and it does not touch the state of the application. So you immediately see the change of the rendering in the browser, and the state of the application hasn't been changed, and you don't
share the screen.
Yeah. Okay.
Right. Thanks.
You're welcome. So what can Figwheel do for me? So as I said, there is a possibility to manipulate the state of the application via the ClojureScript repo. So if I open a correct file here, yeah, here, I have a application state defined in the my app state namespace. So it's this special reagent atom with few attributes. So let's pretend this can be quite a big data structure which is handling some parts of my application. And this login page, so this text is coming directly from this attribute. So if I now go to the ClojureScript REPL, the first thing I need to do is to change the namespace, because the application state is defined inside this state. So changing the namespace, and now I can change the content of the item, and we are going to change how it is called, page title, with new very new login page title. And now enter. Who is there? And I haven't been reloading. When you have a bigger screen, you can really see that it's nearly immediate. So that's what I have described. You can manipulate the state. There is already tooling in the commercial IDEs which allows you to check how the state looks and do it in a much nicer GUI way, so you don't need to use the ClojureScript REPL. But if you have really nothing else, you can still do it.
So that's what function changes
The state of the atom.
State of the atom, like creating new one from the.
No, it's a really mutable structure, and there are some conditions where you can do it. And it's a thread safe change, and yeah, the mutability is only local. So that's one thing you can do with the Figwheel. Second one is that when I have the application state and I don't touch it, I can change. No. That would be hard. Maybe reload the Hangout.
Maybe. Yeah.
Okay, perfect. You're welcome. And now I have been lost for a while. Yeah. So what we have here? Yeah, for example, can someone remember some nice color?
Badass.
Badass. I think Coral should be working. No, here. Yay! Mountain typo. Yeah, and I have different colors, so I can change my CSS files.
I have a question. Does it affect, like, if I have filled in the form There is a input form.
Yeah, there's
in the
a,
page.
it's not connected to the app state, but yes, if you start to type and you have a connection from the input to the application state, it immediately starts to update the state in this Reagent atom. And if you and as I said, this Reagent atom remembers which components are bound to that atom, and they are immediately notified, and they re-render the state if necessary, because it's using the same mechanism as React for identifying what changes are really necessary to be done. So this mechanism is absolutely the same as in standard React. So they are not reinventing the wheel.
Okay.
It's just the mechanism how it is connected is done automatically for you. You don't need to use these stores, or you are using Relay, for example, or this type of libraries. So our CSS are also working, and what we can also do, if I find the file, yeah, this is the hiccup library. It looks a little bit weird, but it has perfect sense that you are creating data structures. So this is the input field with the validation and the label. So you are creating a div which has some CSS classes. Inside it you have a label, the for and type, and these are typical HTML attributes. And again, you are creating the tree structure in the same way you are doing with the HTML tags. So at the end, it's really nothing fancy. The nice thing is that you can combine them, inherit them, call them, manipulate them via macros. You can do really anything what you want.
So what are the structures like the bracket, double door?
The square brackets are like they are called vectors. The curly braces are maps, and the normal brackets, these are lists or also function calls, because list originally means list processor, because Lisp and also Clojure is it's called a homoiconic language. So the source code is a data structure. So a macro in a Lisp-like languages can manipulate its own code because it's manipulating a data structure. That's something which is not usual in other languages. We have macros in C, but they mean something totally different. Macro in a Lisp-like language really manipulates its own code. Here's the original purpose of the Lisp, which was a language for the artificial intelligence. So it's evolutionary algorithm and this type of stuff. So, and what I wanted to show you was that I can, if I find the correct file, layout, yeah, body, header. So, for example, I don't know, here, so after the first header, thanks, we will put a span. So, span with no CSS classes and showing there is a message attribute in the save it, going there, PO, I'm a message, which has been defined in the application state. So I can easily change state of my application, I can change the CSS files, I can change the structure of the HTML, and it gets immediately propagated and executed to the browser. So that's the really powerful weapon of the Figwheel library. So you can really interactively develop the UIs, check if they are working in different states. You can play with it, manipulate it with. It's really nice to work with. So going back to the presentation. Oh, come on. So on top of the Figwheel library, there is an additional tool which is called def cards, and that's using exactly this mechanism. You have one component in a function which is rendering based on some application state, and you can let the def cards render this one component from one source many times with different states. So you can see all those states you are interested in the same moment, and you can check that the UI components look exactly how you want in these states you are interested in. I will not show the demo because that will make the presentation longer, but it works exactly the same way. Yeah, questions? No questions on the Slack? Nobody's asking anything?
Okay. So far not.
Everybody is so stunned.
Yeah, it's amazing.
It really feels like magic. You just change something and it's immediately rendered. So it's really beautiful.
If there are no questions, could you please show a little bit of the demo for these? You mentioned it just before the end of the
Dev
presentation.
cards.
Dev cards.
Dev cards.
Sorry. Yeah.
Or maybe we can just very quickly. From the same guy who has invented the Figwheel. I don't know if they have. Yeah. So this is the 2048 game. So he has two different states, and the same component is rendered. So it takes some time to get it working and to show it. So I didn't include it in the presentation.
Okay.
Yeah, but that's exactly how it works. Because this is the at the state of the reagent atom, and you can just put it on the page as many times as you want. From this description, I will never get an idea what it is working, but there is a really nice presentation from the original author. I can really recommend taking the repositories. There's a Figwheel template, must be somewhere here in his repo about Figwheel.
You can search.
Yeah, I can search. Yeah, that's a good idea. It's not interactive. Okay, maybe this one. Yeah. There is a YouTube video from this guy where he's really live coding this Flappy Bird game with all these changes done immediately. It's something like 6-7 minutes, and it's really amazing. Yeah, because I have been switching the windows. When I will show you one more thing, I make an error in the code. And if I go, you immediately receive some sensitive warning, and you can see what's going on. So this is also very helpful. Yeah, and if you look deeper, it really shows exactly the place in the code where the bug is. It's so clever.
So the app state is like global state of all applications, so it doesn't need to function like parameter, right?
You can do it like that, and it is a recommended way that you have an application state somewhere, and when you are building the page from some of your existing components, you put just the reference to the atom there, and it is not access directed. That's definitely a much better approach for a bigger application. For the demo, it's quite fine. Yeah, but you are right. Yeah, and as I said, there are already libraries which you can use to manage the application state in a much easier way. So you can split it into some smaller parts. There are also some life cycles there. So at the start of the application stopping, there is also a communication via the core async, which is a library which is based on the idea of reactive extension. So you have these channels, and they are communicating with each other in these channels. This is really how the UI are built in ClojureScript.
You're doing some a bigger project, and you need to not only developing the front-end application, but also package with some assets and things like that. Can you use something like I don't know?
Webpack or
whatever.
The current version of ClojureScript has the interoperability with NPM and these tools. So I think there are already guys who are using Webpack to bundle the final application.
Mm-hmm.
So it's possible to reuse these tools. The ClojureScript itself can do this for you, but I think that the Webpack and this type of tools are doing it better at the moment.
Okay. And can you somehow compare using a ClojureScript with, for example, Elm or?
It feels quite similar because the syntax is also very compact. What is not seen from the code is that Clojure is also a strong type system, even if the typing is optional, but it's strong type systems. The same with Elm, but in Elm it's more static. So in Elm you need to explicitly take care about the types in the code. I think it's similar to F#. Here you don't need to so much, but the Clojure will kick you quite quickly when you try to do something nasty with your data types.
Yes, there is a difference because Elm is statically typed.
Statically typed?
You have to know it
Before
at the time of compilation. And ClojureScript is, I think, dynamic type.
Optionally or inherited. Or it can identify the type
at the runtime.
And the runtime.
Yes,
yeah.
it's
and
dynamic.
then it checks. It checks. So it's dynamic but strong. You cannot you cannot do retyping and this type of stuff.
And the type check is then mandatory, or can it be for production systems, for example, turned off?
There was a project, or there is still a project called typed Clojure or something like that, where it was the possibility to, into the meta information of a function, to put the information about the types. Then it was checked, I think, during the compilation, because this type checking was hooked into the compiler. But I have heard that people who started using this typing system on a big project have left the system after 1-2 years of development because it was quite slow, what they say, and they had a feeling that they are losing something because it starts to bound them to the types. It doesn't feel natural for Clojure. And especially it was much slower at the end.
Yeah, I have the feeling that if it would be mandatory type checking on runtime, then it would be really slow because every single function call doing a type check would be disaster.
But I think a strong type checking is only about that you cannot add, for example, number and the string, because they are different types. They don't interoperate. When you have weak typing, it's the opposite of the strong. You can add the string with number. It's, for example, in JavaScript.
And it gets retyped.
Yes, it's
and that's what's not allowed in the
it is not like checking the type at the runtime. It is crashing when it's wrong.
For example, Haskell is a good example. It does not compile at that moment. Because if you want to add string to number, one of them must be converted via some function with correct outputs first. So if you want to make hello plus number, then you need to wrap the number into the number to string.
On the compile time.
On the compile time.
This is not the case here, right?
No,
you said it's dynamic typing.
No, but this is a case in Elm, for example. Elm is also not allowing this type of stuff.
This is also static typing in Elm. Yes.
Static and strong.
Yes. But this is dynamic.
Dynamic and strong.
And strong. Okay. So it's
because static and static and weak, dynamic and strong and weak are really two different categories, and you can combine them.
So I'm just guessing who's actually doing that crashing when you said that if you try to, it's not.
Then it depends on the platform.
After
that's a discussion. Okay, but no, there is nothing more from my side. Who is interested in functional programming? We have a living channel on Slack.
Finally.
So really good to have new guys here. So whoever is interested in this modern way of development is more than welcome. Yeah, modern invented in 50s. But
like 60 years old.
Yeah, it's 60 years old. Modern. 60 years, again modern.
Hopefully.
Hopefully, yeah. And thanks a lot.
Thank you.